Okay, review of right triangle trig. Okay, let's get going here. Thanks, Knack. All right, so we already did this on the board, so this is going to go by a little bit faster. That way you have time to practice and time to master. Remember we talked about the sides that are relative? The ones that are relative will be op and edge. Those two can switch, op and edge. So depending on which angle you're working with, op and edge will switch. Okay? Stop talking, please. Okay, if you're going to care about angle O, then which side is op? AB. Hype is clearly here, across from the 90. That forces ADJ to go here, yeah? Now if I switch colors, I care about angle B now. Now which side is op? This guy's op, and then this guy would have to be ADJ. All right? So op and edge is relative to which angle you're working with. Okay, they in the book are caring about angle X, which is down here at O. So op over hype, AB over OB. You can handle that? All right. Let's do this then. Let's just jump right in. Okay. So this is nice. Let's put a divide right there. The first one cares about which angle? Angle X at F. So then let's mark it. Let's put on our training wheels. Straight across from that, this would be op. Find the 90 straight across from that. This is hype. That forces ADJ. You think you can handle that? Some people don't even need that. You don't need those training wheels. Okay? Any hoo-ha? Sine X. So katoa. So. OH, 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 OH. DE over FE. Absolutely. But we're just going to use the... You could, yeah. Okay, cos X, ADJ over HYP. So then we'd have DF over FE. And then op over edge for tan. TOA, TOA. DE over DF. Huh? What about Donald Trump? Wrong. Wrong. Which one? Okay, so let's do something a little bit different for this one. Let's go with the lower cases. Let's go with the lowercase letters across from the uppercase vertices. And let's try this without training wheels. So we're interested in angle Y. So then for sine of Y, you need the op over the hype. Beautiful, you guys. Cos. There's no, that's a V. It's a V. V over S for cosine. V over S. Beautiful, beautiful. And then for op over edge, T over V. Good job, you guys. If that is this problem, because Math 10 is so far away for you, or Trig, when the work time is, just call me over and I will sit with you. All right. Pythagorean theorem. Please just look at me for a second. Let's say we have a triangle like this. Sorry, I gotta do one thing here. So just give me 1 second. Okay, so here's this triangle, right? Let's call this 4 and this 3. How could we get the hypotenuse C? This is Pythagorean theorem. It's just above where we're doing class example 2. Good. C squared is equal to A squared plus B squared. Stop, you guys. A and B are the legs, not the long side. So A and B are 3 squared and 4 squared. How to solve a Pythagorean? How would you get rid of the C square? You'd have to square root both sides. That's just a shortcut that you can do for Pythagorean every single time if you're solving for the long side. Okay. So watch how quickly you can do this. Second function square, and then you have a bracket open. If you have an older calculator, just make sure you open that bracket. 3 squared plus 4 squared. Pythagorean theorems can be done in a simple keystroke. Okay? So it's the long side shortcut. Okay? So the answer to C is 5, and it's the long side shortcut. That's what I call it, long side shortcut. Okay, super quick. Super quick. Okay. Square root of 25 is 5, yeah. 9 and 16 makes 25, and square root it, yeah. Okay, let's look at this one. We already know the long side is 25, so we're trying to solve for a short side. So when you jot this down, if I want to solve for the short side, Carter, focus on me. If I want to solve for a short side, then I need to subtract one of them over. It doesn't matter which one. A and B are the legs. Is that okay for you guys? Opposite of plus is minus. Move it to the other side to isolate. Now, opposite of squaring is square rooting. So, boom, boom, and you solve for B. This equals B. This is your short side shortcut. Okay? That's your short side shortcut. All right, so to solve for ST, the length of ST, it's a right angle triangle. I know 2 of the sides, so I'm allowed to use Pythagorean theorem. I'm just going to do a shortcut. If it's a short side, just subtract, you guys. If it's the long side, you add. Blooms? If it's the long side, you add. If it's the short side, you subtract. When you're subtracting, just put the big number first. Why do you think that matters? So it's not negative. Beautiful. So that's all you're looking for. And that answer, I believe, is 24. Eh. If you already know a way and you've mastered this, that's perfect. But you can share with me after. Okay. Let's do this. Sine r. All we care about here is finding the appropriate ratio. We're not going to do any math, just the ratio. So it's just definitions. Sine r. And we can now put 24 here. So for r, the opposite would be 24, and the height is 25. Cosine r would be 7 over 25, and tangent r would be 24 over 7. For all those ratios, could you get a corresponding decimal? Could ratios be expressed as decimals? Yeah. So whether it's a ratio or a decimal, don't get confused by that. But most of the time it's ratios, for it's like side to side. Okay, let's jump to angle S. Sine S would be 7 over 25. Cos S would be, yeah, 24 over 25. They switch. And tangent S, opposite over adjacent, 7 over 24. And then it says comment on the relationships. Okay, so it's like these guys, like cos R is the same as sine S. See that connection? Good, 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 good. And then for the connection between tangent, is just a reciprocal. They flip. They're just reciprocal. They flip. Okay. Cool? Okay, calculating angles. Calculating angles, remember on my whiteboard? All you got to use is second function. Okay, use the second function. All right, let's just scroll down to this part. So here we go. Some trig thing, sine, cos, or tan. What goes next to the trig thing? A side or an angle? Good, it always trig thing and then angle. Now what's over on the other side? A ratio. So is 1.2 a ratio? Yeah, it's 12 over 10. Or 6 over 5. So could it be a decimal? Yes. Could it be a fraction? Yes. Do you care? Just be aware that it could be either. Yep, 12 over 10. Very nice. So, how to solve for x? Could I divide by tan on both sides? Is that a thing? That's not a thing. Could I subtract by tan? No. So what you need to do is the opposite of tan, which is inverse tan. Inverse tan. Okay? Now it just comes time for house cleaning, so take out your calculator, make sure you know how to do this. This is just so everybody is on the same page. If you have my calculator, you're looking for hitting the mode button, and then the degree has to be highlighted. So scroll down to the third row and then go over and then hit enter, make sure it's highlighted. To get out of this screen, just hit second mode. It's the little quit button right there. Second mode. And then just to make sure you got the right thing going on, go sine 30. Sine 30 needs to be half. Okay? If you can test this out, sine 30 is half. That's how you know you're in the right spot. You should, but I was just lazy there. Everyone's cool with sine 30? Anybody got one of these ones? You're going to have to look for DEG in the screen, or like a capital D. Yeah, so you're good there. See DEG? So sine 30. You're good. There's a DRG button. I didn't change it. It was already like that. That one, DRG. See, now it's RAD, GRAD. That's for different, like, because we use degrees. Yeah, yeah. Okay, let's try the question now. Okay, telephone pole. This is 12. You guys okay with that? Supported by a wire, 14 meters long. So here's the supported by a wire. I believe it'll look like that. Fixed to the top. Yeah, I got a little ahead of myself, but it says fixed to the top and to the ground. So that wire is worth 14. Okay? And then I'll draw the ground now. Here comes the ground. It's green because it's grass. Okay, so there's lots of stuff that we could do here. Lots of stuff that we could do here. The right angle's right here. So let's just go find this bottom side. I don't know any angles. So what can I use to find a side? Pythagorean. Is this a short or a long? Short. So then square root, are we adding or subtracting with short sides? Subtracting. Adding's for the long side. Put the big one first. I love it. Whoever's doing that. And then there you go. So you can find that one down there. Anybody get it? Do you have a bracket? Do you have a bracket, whoever said that? I got 7.2. 7.2. Now it's asking for the degree angle between the wire and the ground. So that's this guy in this corner. Okay. So we want that purple angle. The purple angle, that's the one we're trying to solve for. So let's just pretend we didn't know 7.2 and all they gave us was the 12 and the 14. That's all they gave us. What side would 12 be relative to purple? And 14 is, of course, the height. Now this is the thinking that you have to do. You go into your vast depths of your knowledge and you are whispering to yourself as you write this test, Sokotoa, Sokotoa, Sokotoa. Now when you are whispering to yourself, listen, I need to find the relationship that has O and H. Because if I just started this problem and I didn't do any work up front, I don't know the bottom. What's the bottom? What label is the bottom? Adjacent. I'm like, I don't know anything about the bottom. So which formulas can't I use? Because they have an A in them, right? You see they have A? Well, if I don't know nothing about A, I can't use them, so I have to use sine. So then I'm like, okay, sine of the angle, which I'll call theta. This is theta down here. Op over hype, 12 over 14. How do I cancel a sine? Sine inverse. That's all you have to do. Sine inverse. And you have to be in degree mode. Second function sine, what was it again? 12 over 14. 58.99. So let's just go to 59 degrees. That's so close to 59. So if this is 59 down in the corner, all I have to do is go 90, take away 59, which is 31, and that's up here. You just solved everything you could possibly want with that triangle. You can get the missing sides, you can get the missing angles. This is what's expected for a Math 10C student. Okay, so that's why this is review. If you're in Physics 20, you got to know this as well. Science 10, not so much. Math 10, all the maths, and Physics 20, that's pretty much what you need this for. Let's keep going. Let's go to question 4. All that stuff up there, I can show it to you in this question. Okay? All that's... This right here, what you can write on the side here, you can write finding sides. And you can say cross multiply, because that's what you're going to be doing. Finding sides, you got to cross multiply. You'll know the angle, but one of those ratios you won't know, and then you got to cross multiply. All right. So we want AB and AC. Okay, so which one do you want to do first? AB. Okay, let's call AB X. Sure, let's do that. Little c. Then this would be little b, and this would be little a. Let's just be consistent with what we've been doing. So thank you. All right. Off to the side here. Let's say I want C. So first of all, what label is C? According to using 74. Okay? And what's the only other thing I know about? The 109, right? So what label is 109? Adjacent. So then I'm like, okay, so ka toa. Okay, which one do I know nothing about? Hypotenuse. I don't know nothing about the hype. So I can't use this and this. I can only use tan. So then I'm like, okay, write down the formula. Tan theta is op over adj. Where I see theta, I can put 74. Theta is the angle. Now, op is little c, and adjacent is 109. Some people need a little placeholder over here of 1 to help with the cross multiplying. But essentially what you want to do is isolate C. So 109, which is downstairs on the right, needs to come upstairs on the left. If you understand cross multiplication in a different way, you always times the two numbers and divide the thing across the unknown. So it's these two times divide 1, which is essentially what's going to happen. This 109 will get put right there. So you have 109 multiplied by the tangent of 74, and that will equal C. And remember, tangent of 74, Steph Blooms, is just a number. Tan 74 times 109, Make sure you close the bracket on that 74. Like, don't have it all messed up. 380.12. Let's just put 380.1. All right. So that was 380.1. So now you have two sides, yeah? How could you get the missing side? Yes. And is it the long side? The hype is what we want, right? You want the hype? So the hype, if we're doing the long side, it'll be a square root with plus 109 squared plus this 380.1 squared. Shortcut goes quick. And that last answer should be saved in your calculator with all those decimals. I would just hit the square button. Then it says answer squared. Plus 109 squared, square root that result, you get 395. If you can't get 395, put a little star beside that, and I can come around and help you with that later. You guys feel okay about that? Oh, beautiful. All right, large tree, transported. The tree is held vertical by means of two wires of unequal length on opposite sides of the tree. So I don't know how we're going to draw this yet, but you got something over there, you got something over there, and they're going to hold it up, okay? One of the wires makes 48 degrees with the ground. Okay? So 48 degrees. Could you estimate 48 degrees? If that's 90, what would 45 be? Half, right? So you could get a pretty decent 48 degrees. Like this. It's just a sketch. Roughly 48 degrees. Okay? So one of the wires makes 48 to the ground. Done. The other wire is 12 meters long and makes 56. So this will be steeper, yeah? So it should go higher. If it's steeper, mm, 56. Well, it depends how long it is. So I might be wrong. Oh, it says, we got to keep reading. Both wires are attached 3 meters down from the top. So this is both garbage. These are both trash. You use a pencil though, right? So if this was the top, why would you do that? Man. You got to go down 3 meters. So they are connected to the same spot. That looks a bit better. All right, so they gave us more information about the triangle on the right. They told you the actual length of the wire. So in terms of your problem solving, you got to start on the triangle on the right because that's the information you know. All right. Now if you look at that triangle, which line do those two triangles share? This middle line, right? So that is a piece of information that can be shared between the two triangles. So let's go and find this distance here. Let's find this distance here. Let's call that, what do you want to call that? H for height? Let's do that. Call it H for height. So what relationship is going to relate the 56 degrees to H and 12? Sine, cos, or tan? Yeah, you got to use the hype, right? 12 is the hype. So you have to use 12. Now is H the op or the hype? Or pardon me, op or edge? H is clearly op of 56, right? So you have to use sine. So then we're like, okay, sine of 56 is equal to op over hype, H over 12. And then that 12 can slide up to the top on the left. And you solve for H. 12 times sine 56. I got 9.9. 9.95 pretty much. And that is meters. Is that the height of the tree? No. Plus the 3, right? Plus 3. And then the tree height is 12.95 meters. Yeah, it wants the height of the tree. And to one decimal place, this 5 would not actually be there. So it's just 12.9. Let's just get rid of that 5. No, because it's a 4. You guys okay with the cross multiply? So you got to be able to label, you got to be able to set up, and then you got to cross multiply. Okay, the length of the other wire. So now I know for the other one, this is 9.9. And then I'm trying to find this one. Is it the same trig function with 48? 9.9 is op, and question mark is hype. So is it still sine? All right. This time though it's going to look a little bit different. When you do sine of 48 and you put op over hype, it's question mark over 9.9 or other way around? I'm going to call that question mark y. Now I want you to compare, I'll put boxes around them, compare this and compare this. What's the key difference between the unknown? Here the unknown is in the top, right? And here the unknown is in the bottom. So to solve the one we're doing right now, the y in the sine 48 will cross multiply switch, I call it. So this time the solution is a little bit different. You can't just slide the number up over and times. You actually have to do a divide. Okay? And the way I would explain this, little y downstairs on the right is upstairs on the left. And the sine 48, which is upstairs on the left, is downstairs on the right. That's a cross multiplication switch. That's the only place they can go. All right, so now you're looking for a division, and the answer should be 13.3. If you can't get 13.3 to show up, You got to tell me, and then I can come around and help. Okay, now part D, the horizontal distance at ground level between the two wires. So I need this, x1, and I need this, x2, and I got to add them up. That would be the total distance. You guys okay with that? So x1, I'll use short side Pythagoras. 13.3 squared minus 9.9 squared. x2, I will also use short side Pythagoras. 12 squared take away 9.9 squared. Short side Pythagoras. That's how I introduced the lesson. One of the first things I showed. Pythagorean theorem, short side uses a subtraction. Studied in grade 9. Okay, so x1, I got 9.0. Oh, this is 13.38, so did you guys, this should actually be 13.4. It's rounded up. Right, this, if you round early, you're going to have issues. And this one I got 6.8. All you gotta do is add them up. Okay, I feel like I'm done with this question. I don't want to do any more of it. And I feel like I've been up here for a while, so enough is enough. You need that slide still? So the assignment follows. That's all you have to worry about this weekend is this one assignment, and you have almost 45 minutes.